Go ahead. Yes, Athiya, go ahead. Hello.
Hello, sir.
Yes.
Sir, can I ask you?
Sure, sure. Go ahead.
Sir, I don't understand our lab assignment. Can you
La-
please explain?
Lab assignment. Are they
Yes, sir.
uploaded the lab assignment?
No, sir. In Slack.
So,
Yes, sir.
in Slack.
There is a
So,
there is an option of lab assignment, graph plotting software tutorial Dismos.
yes. Go. Yeah, yeah. Desmos or the graph software, right?
Yes, sir.
So, what is your point about that? I didn't get you. So, which part you didn't
Sir, I don't
understand?
understand our lab assignment. Like,
Newest.
Actually, there is no question. Actually. They just
There is no
uploaded the.
question.
No, sir. I mean, in there is a section in Box called Lab Assignment, and
Mm.
there is some videos that how to use demos
Mm-hmm.
or this, but there
Yes.
is no lab file,
Yes.
sir.
Yes.
It will be uploaded later.
Oh, the book. Yeah, exactly. So these software or the videos tutorial they give you to cope up with that, how to use this software. That's why
Yes.
they uploaded this video. Go through this video, try to familiarize with this software, either Desmos or Graph software, which one you prefer. You have to use this software to make your graph using that simulation data. So that's why they uploaded this video tutorial for the lab purpose. They will deploy the fast lab probably in the next week.
okay, sir.
Sir,
Do you
do you
understand,
have,
Sultana?
Yes, sir.
sir,
Yes, Sakib.
do we have any time slot for lab? Like we have 2 live session with you every week, but is there any other time for the lab?
No, there will be no live session for the lab. Although there you will find out some schedule in your class routine, but there will be no live session for the lab. What they will do, they will basically make a instruction how to perform the lab, and they will basically uploaded that instruction into the BUX lab section. So you have to follow that instruction to perform the lab. Once you complete your lab, you answer the questionnaire. They will ask into that lab, then you will submit your lab through the BUX, or they will give you the link how to you have to submit your lab report. That would be the procedure of the lab. Did you join to the lab Slack channel?
Yes, sir.
Yeah.
Hello, sir. Can you hear me now?
Yes, I hear you, Athiya.
Yes, sister. So I have problem regarding the example problem 2 given in our handout or practice sheet. So they were saying that consider 2 point P1 that is called coordinates of x1 and y1, and P2 with coordinates of x1 and x2 and y2. That are separated by distance d. Find the vector A from the origin to the point on the line connecting P1 and P2 that is located a distance A from the point P1. So I couldn't understand how to
Hmm.
solve this problem.
Oh, that's one. Basically, you have to find out that point over here. Which one you were asking? I don't have
Given
the
it is
handout, bro.
given in yes sir. Lecture note 1.
Okay, I'll talk to you about that one after my after the class. Wait for that. I'll discuss that part also. Any more question except this one?
No, sir. No, sir.
Okay, fine. Give me a moment. Okay, all right. So I'm going to share my screen with that. So, so we are discuss about that vector scalar, right? So we talk about basically your addition and the subtraction, and also the multiplication of that vector, right? We discuss about that procedure, how to do that. Right now today I'm going to solve some problem related to that this thing. So first, say this one. So this is a cube which has a length is 2 meters. So this cube, say this is your x-axis, this is actually y-axis, and this is actually the z-axis. So they asked me find out that angle, the phase diagonal, the angle between these two phase diagonal. What excuse me, what would be the angle between this phase diagonal? Do you understand this question? So if you want to find out that this angle between that phase diagonal, you have to express that one as a vector, right? Say I'm going to express this is the vector A, and say this is the vector B. I have to find out the angle between this vector A and B. Then I can find out what would be the angle between these two vectors. Now, my job would be how I'm going to express this vector A and the B. That would be my first job, right? To solve that one. If you could find out that vector A and B, then I can use that formula, dot product A dot B would be basically AB cosine theta. That formula I'm going to use to find out that angle between these two phase diagonal. Phase diagonal means you have a face, say this one is a face that is in the YZ plane. That phase diagonal has a diagonal A vector, and another face which is actually the XY face or XY plane. That face has a diagonal which is the B. Then what is the angle between these two vectors? That's my question. Fine, since I know that the length of this diagonal is would be basically that you could find out, right? That's with the A root 2. So no, it's a 2. So this would be basically that 2 square plus 2 square, so 4, right? 4 plus
Yes,
4
sir.
actually. So that's going to be basically the 8. So 8 means actually 2 root 2. So that should be your length of the diagonal. But I have to find out that I have to express that is in a vector actually. So that's when if I know the coordinate of this point, then I'll be able to express that one is a vector, right? I know how to express that position vector. This A is basically, if you consider this is your origin, then this one is a position vector, and this B is also a position vector over here. In that case, I can find out that one, say that what would be the position of this point. Say if you say this is the point B, and say this is actually that C. what would be the coordinate of the point B? To find out that coordinate, so it should be basically that's going to be the coordinate of B would be, I can write, is with the 0, 2, and 2. Am I right? Do you get my point? It's very important. If you can understand, then it's very easy. So I just find out that point. So I don't have to go to the along to the x direction. If I move that direction, y is 2 unit because the length of this cube is the 2, and I have to come also the z direction 2 units. So that's why it says 0, 2, 2. Same way we can write for the C point, it should be the 2, 2, 0, right? Then I can find out, say that the vector A, so position vector. So what would be that? It should be that 0 minus 0 is going to 0 I hat, I don't write that one, plus 2 minus 0. Look at this. I'm finding out basically that position vector OB. Right. So that's why I'm writing final minus initial always, or I can write one more line for you here, so that you can understand easily what I'm going to, and this will be very helpful for the case of the motion in the second chapter. So that's why I look at this. I'm writing 0 minus 0 because this is 0 and my origin all are 0. So that's why 0 minus 0 I hat plus 2 minus 0 is z hat plus 2 minus 0 is k hat. Do you understand that one? Then
Yes,
the A
sir.
would be basically, this is 0, this is going to be the 2j plus 2k. Right, so this is my vector A. Fine. By the same analogy, I can also find out the vector B. So in that case, vector B would be 2 minus 0 I hat plus 2 minus 0 z hat plus 0 minus 0 is k hat. Look at this. I didn't write down that 0 minus 2, right? My final point is that one, C point. So I'm moving from O origin to C. So that's why this is my destination, C point. So we find out the difference, these 2 points, and difference always will write down final minus initial point. My final point is C, which has a coordinate 2, and my initial point is 0, which is at the origin. So that's why I write down the 2 minus 0, and same way 2 minus 0 z hat and 0 minus 0 k hat. If I come to from C to B, then I'll write down, in that case, C is my initial point, origin will be my final point. Then the vector would be basically the reverse, right? In that case, it will be 0 minus 2 I hat, 0 minus 2 z hat, and 0 minus 0 k hat. So vector would be basically in the opposite direction. So that's how we can find out or express the vector in terms of coordinate actually. So then it's going to be the basically the 2 I hat plus 2 z hat. So this is my vector. Then I have to find out the magnitude of this one, which is length of that diagonal, right? It should be 4 plus 4, which is 8, is to be the 2 root 2. Same way, the B would be also the magnitude is 2 root 2. Am I right? Right? Now I can find out the angle. So I will write down, say, A dot B would be AB cos theta. I'm going to find out the theta from there. So theta would be basically that cos inverse A dot B divided by AB. Right? What would be that A dot B? So A dot B, if you want to find out separately, look. Yes, it would be.
Sir, 4, it would be 4 A dot
So
B.
yeah, it would be 4 definitely, because I'm going to multiply by the vector A. First 2j 2y, that should be 0. 2j 2j, that's going to be 4. Then 2k with 2i, that's going to be the 0. And 2k with 2j, that is also going to be the 0. Then I'll find out A dot B would be basically. Should I show that one? A dot B is basically the 4. Should I show that one, guys?
No, sir.
Yes, sir. Please show it.
Come on, guys. You have to do by yourself this thing. I'm doing for this for the last time for you. The next session or next few days, I'm not going to do that type of calculation. You have to do by yourself that thing. So this is, look at this, 2z dot I, right? 4z dot I plus 4z dot j. I multiply with 2j with rest of this vector. Similarly, 4k dot I and plus 4k dot j. Now using the vector unitary properties of that vector, we discuss about this one. I dot I is 1, but I dot j basically the 0. We'll use that one over here. So if you do that, then I should use different color. So this z dot I would be 0, z dot j would be the 1, k dot I would be the 0, k dot j would be also the 0, and this thing would be basically the 1. Then I'll find out that, a dot b would be basically that 4. So that's how actually we will find out that a dot b will be basically that 4. Fine. Now I'm going to plug in that value. So theta would be cos inverse a dot b, actually that 4. And what about this is going to be the magnitude of a, actually the 2 root 2. And magnitude of b is also that 2 root 2, right? Then this
8.
4 will be cancelled out. I will find out the 2, right? So then what will be that angle in that case? Half. So it's going to be 60 degree. And theta would be there, because cos 60 basically that half. That is to be the angle between the two face diagonal of a cube. But some of you may consider that, but the angle between these two planes is 90 degree, right? Because if you think about that plane, in that plane, vector A is towards the diagonal, and second plane, which is actually that one, in that plane actually the vector B is over there. But these two planes are perpendicular to each other, but the angle between them is 60 degree. Don't think about the angle between these two vectors would be also the 90 degree. It's not. Fine. So this is the second question. So this is a quadrilateral. It has 4 points. So A, B, C, and O. They give you also the coordinate of this vertex actually. So this is origin, which is 0, 0. This is say that A, which is 3, 2, 0. B is 4, 6, 0. And that C is 1, 3, 0. Now they ask to find the acute angle between the diagonal of this quadrilateral. So this is one diagonal and this is another diagonal. Now they ask to find out the angle, acute angle. So this one will be acute angle, which is less than the 90 degree, right? So this is to be that acute angle you can find out, but that would be, this is to be obstruct angle, which is greater than 90 degree. So they actually find out that angle. I hope you can solve this one. First, I'm not going to solve this one for you. This would be your homework. Try to do at your home. This would be your homework. So what you can do, you just find out the vector OB and vector AC. Then find out, or vector CA, whatever you write down, this will be the CA. Then find out that vector, and then use that these two vector to find out the angle between these two one. I hope you can find out. This is basically the same as the previous one. That's your homework. And I'm going to save the answer. So answer would be basically that this, I'm just giving you the answer so that you can solve this one. Is going to be the answer, the angle this theta, which is over here, is going to be that 82.53. That's really that answer of that one. So there is a question over here. Say you have three vector. They given, say that vector A is 5 I hat plus 4 j hat minus 6 k hat. Vector B is minus 2 I hat plus 2 z hat plus 3 k hat, and vector C is 4 I hat plus 3 j hat plus 2 k hat. They give that one. And now the first question they ask you, I'm sorry, I didn't get this question. I have to write down one. First question is, say the question number 1. First question is that in unit vector notation, what is R if R minus A plus B minus C equals 0? This is the first question. Yes, in unit vector. Second question, calculate the angle between vector A and B. This is the first. Second question. Third question is, what is the component of vector A along the direction of vector B? Question number D. What is the component of vector A along the perpendicular direction of vector B, but you should write that one also. But AB would be in the same plane. But in the plane of AB, the same thing. Plane of AB. Question number E. Calculate the angle between vector R and positive z-axis. I could also ask you the negative z-axis. The process are same. And calculate A dot B cross C. Also mention the dimension of this quantity. This is the question. I'm sorry, I have to write that one. I am not prepared for that one. So fine. Can you solve this, the first one? I hope you can solve that one.
Yes, sir.
Right, it's a very stage. Yeah, do that one and send me the answer if you can solve, all of you. Will you solve, or I'm going to solve for you? I hope you should also do that.
Sir, I think we can solve this one.
Yes, what about the others?
Yes, sir, I can do that also. I can do that
You
also.
can do that also. So it's very, yeah, that's fine. That's good. So fine. Say, okay, let's do that, because otherwise it will be time killing for me, right? I have a plan for another 2 problems to that. Say A is basically nothing. They are asking to find out the vector R in unit vector notation means, remember, unit vector notation means in terms of I, J, and K. That is the unit vector, right, in the Cartesian coordinate system. So that's why they actually find out the vector R if R minus A plus B is a vector and minus C equal to the 0. So then I can find out that R from there. So R would be basically, say, A minus B plus C, right? It's a basically addition and the subtraction of these 3 vectors. They will check that whether you can do that at a time. So this is nothing, it's a addition and the subtraction. If you do that, your answer would be basically that 11i. Do that by yourself. I'm just giving you the answer. So check that your understanding level, whether you can add and the subtract of more than 2 vectors at the same time. So 5j, 11i plus 5j minus 7k. So this would be then vector R. Yes, any question?
No, sir.
Okay, fine. So this is the answer of the question number 1 or question number A. Now the second question, calculate the angle between the vector A and B. That one is also, you can do that using the dot product, right? What is the vector A dot B would be basically AB cos theta. That would be my angle between these two vectors, right? So how I'm going to find out that one? To find out that one, I have to use that dot product and the magnitude of this one. What would be that? So is the theta would be basically that cos inverse A dot B divided by magnitude of A and magnitude of B. So I'm going to just put that value. So A dot B, if you do that, you'll find out, or I can do, look at this from there. Say A dot B would be minus 10 plus 8 minus 18, right? So you can find out. So this would be minus 10 plus 8 minus 18. That's going to be the minus 20 divided by root 77 and root 17. You can find out from that magnitude how to find out the magnitude of a vector. I hope you can find out that one. So then if you solve, you'll find out that theta would be 123.5 degree. So this is that answer number 2, question number B. I find out that angle between these two vectors. Right, this is very straightforward, one A and the B. Now the C is very interesting, C and the D. What is the component of vector A along the direction of vector B? Can you guess? Can you make a guess? What would be that?
Sir, A cos theta. It
Say,
will be equal.
I'm going to find out. It's a three-dimensional case. I'm not going to draw that. It's the arbitrary direction. So this is my vector A. Say for simplicity, I'm assuming. So this is the vector A. I'm not. Sorry. What do you say?
Sir, are you asking me?
And say this is the vector B. Right. Now I find out the angle between these two vectors is theta. Then the component of vector A along the direction of vector B, which would be basically the projection of vector A along the direction of vector B. If I know that, then this is would be basically that A cos theta, right? That would be the component of vector A along the direction of B. I don't know whether it's towards the x-axis or z-axis or y-axis. Which direction actually I don't know, because it's a three-dimensional. You cannot say that unless you draw the vector, right? Did you get my point? Now I can find out this one in the two way basically. One, you can, since I know the angle between these two vector A and the B, right? Then I can say two way I can find out. I can use that one. Say that A dot B is basically that AB cos theta. From here, I can find out A cos theta would be A dot B divided by magnitude of B, right? This is one way, which would be A dot B is basically minus 20, and magnitude of B basically is root 17. If you do that, you'll find with a minus 4.85 meter. And why this minus sign actually? It is basically the opposite direction. It's not the actual that one. So actual one, if you draw that, and angle is 123 degree, you can predict that one also from that one. See, if the vector is to I cannot draw in that way. Say somewhere it would be, if I want to draw that exact y-axis, then if the vector, if I want to draw, it's a minus 2, 2, 2, minus 2, 2, 3, minus 2, I have to go to the minus 2, 1, 2, and y direction 2, 2, and z direction would be 3 over here. Somewhere would be over here. So it's very difficult to draw in the three-dimensional case. But my point is, your this is negative because that a component say that the negative towards the negative x direction is the x component. So that's why you find out that way. So I cannot draw over here in the three-dimensional case. I have to do in, or I have to do the rearrange this axis. So anyway, so you can find out a cos theta. It means that minus 0.85 x direction. So this is actually the component of vector A along the direction of vector B. Along the means it is basically in the opposite direction, but in the same axis. It's a parallel. Fine. This is one way, or another way you can find out. You can directly find out from this one. Put the value of magnitude of A, which is root 77, and put the angle. Angle is basically cos of 123.8 degree. Then you will also find out this will be minus 4.85 meter. So that's how actually you can solve this part, the question number C, which is actually that component of vector A along the direction of vector B, but in the negative direction. Fine. Now this fourth one, they actually find out basically the component of vector A along the perpendicular direction. So perpendicular direction, I will use basically two way also. You can write down A sine theta directly. Do that 77 sine of 123.8, 123.8, no, it should be 123.5. Is 123.5, right? Yes, 123.5. I'm sorry, it's not 8. We should write 123.5. So this is 123.5. You will find out that's going to be positive 7.31 meter. This is one way you can do that, or another way you can use basically that cross product also. So cross product, or you can write down that A cross B magnitude. I'll only just find out the magnitude of A, magnitude of B into sine theta. I'm going to find out from A sine theta from here. So which would be that A cross B is magnitude divided by magnitude of vector B. If you do that, you'll find out that this will be 7.31 meters. So this is actually that component of vector A along the perpendicular direction of vector B. So this is the answer number E5. Now what about question E? Calculate the angle between the vector R and the positive Z axis. So fine, I have to, let's draw the three-dimensional case, then it would be easier for two. I'm just trying to give you the idea. So what is that? So this is your positive x-axis. This is your positive y-axis, and sorry, use that line from there. So this is your z-axis. Now I'm going to draw the vector r. So vector r, what is that? 11i 5j minus 7k. 5 unit to the y direction and minus 7 unit. 11 5 minus 7. 11 5 minus 7. So 11 units, I'll go. This is the 11. Say 1 2 3 4 5 6 7 8 9 10 11. In the 5 unit, 1 2 3 4 5, and say that 7 unit, say minus 7 actually. So my drawing is not exact, remember. So say it will be towards over here. Say this is with the downward direction. Then I can draw the vector r. This is my vector r. Now they ask me to find out the angle between this one with the positive x-axis, positive z-axis, right? That one they ask me to find out that one. So now clearly from there you can predict the angle is definitely that greater than 90 degree. It should be obtuse angle, right? So obtuse angle. So which is greater than 90 degrees. So I'm going to find out that one. So what I'm going to do basically use that formula that A dot B is basically that AB cosine theta, but I have to modify this one because for this case, I have one vector which is R. So this is my vector R. I'll write down the vector R. And what is the second vector? Second vector is towards the Z direction. I know there is a known vector towards the Z direction, which is say that the K hat, right? And this is the magnitude of R. This is the magnitude of K. And this is the cos theta. Then I can find out the theta from there. So theta in that case would be cos inverse K divided by magnitude of R and magnitude of K. Then I can find out what would be that, say cos inverse R dot K, which would be, if you find out, because look at this, I'm going to take the dot with that vector R. So vector R actually the 11i 5j minus 7k. I'm going to multiply this vector by the k. So k dot k would be 1, z dot k would be the 0, and I dot k would be the 0. So that's mean this 11 and k portion or x and y component will be the 0. Only I'll find out the z component. That's with the minus 7. So find out, and the magnitude of vector k is basically that 1. That method actually you could find create, right? Or in any vector actually you can find out the angle between using this formula. That's the case actually. Yeah, fine. So this is the question number E, and question number F. They ask you calculate A dot B cross C. Fine. So first I'm going to do basically find out, I have to calculate A dot B cross C, right? First I'm going to find out that B cross C. and the vector b, I just place that coefficient of vector b is to the -2 plus 2 and 3, because vector b was -2i hat plus 2j hat and plus 3k hat. Look at this, -2i hat plus 2j hat plus 3k hat. And c is basically 4 3 3 2, and vector c would be 4 3 2, right? Then use that determinant process actually. So because c, if you 15i, right, I'll find out, say that these two components will be cancelled out, or whatever process I'm going to take this one. 2 into 2 is 4 minus 9. I'll use the plus sign. I use the normally the plus. Then I'll write down, if you use the plus sign, then it's going to be the 12 3 into 4 minus minus 2 and plus 2. So that's going to be that plus 4, because you have a minus in the formula, and there you, if you multiply -2 and plus 2, you will find out the -4, and that minus sign is going to be the plus 4 plus k hat. You can use the minus sign. In that case, this is going to be the reverse. It's with the -4 and -12. Anyway, whatever the process I talked about in the previous class, you can use whichever you like, but do not make a mistake doing that one. And this will be the -6 -8, right? Then I'll find out this is a cross product, which will give me a vector because c is going to be -5i hat plus 4j hat. I'm sorry, not 4j hat. 16j hat and minus 14k hat, right? This is the b cross c. Now I'm going to take the dot product of this vector with the vector a dot b cross c. So I'm just writing. So what is the vector a? Vector a is plus 5 I hat plus 4j hat minus 6k hat dot minus 5 I hat plus 16j hat minus 14k hat, right? Then what it will give me is I'll write. So this is would be this similar quantity will be survived, right? I'm not going to say it's a basically ax bx plus ay by plus az bz. In that way, I will do that. So it's going to be the -25 I dot I, basically the 1, but rest of the term will be the 0. Then plus 64, then plus 84, -14 and -6. So if you do that, this one will give you basically that 123. That's the scalar quantity because a dot b cross c basically that scalar. So that's why it should be that it would be 123. This is actually the answer number 1. And they also mention the dimension of this quantity. It should be basically the meter cube. It's a volume, right? So if you want to say the b cross c is basically will be the meter square, say that the vector a, b, c actually in meter, if it is given, say a is basically that 5i plus 4j minus 6k meter, and b is minus 2i plus 2j plus 3k meter, and c actually 4i plus 3j plus 2k meter, then the dimension of this quantity is going to be the meter cube. That will be your answer of that one. It's fine. Any question over here? Do you have any more question over here?
No, sir.
No, sir.
No question. Okay, okay, fine. Let's do another case actually. So let's see whether I can do that one. I don't know. So this is say that axis, so this is the x-axis, this is that y-axis. There are some vector. Say this is the vector A, which create a angle with that axis is 40 degree. Another vector. So this is the vector D over here. Another vector, say that this is the vector C, which create an angle over there, say that 25. And another vector, say over here, say that this is actually the vector B, so which create an angle. This angle is 19 degree. Now they give you some information, one information. The magnitude of vector A is 1.5 meter. Magnitude of B is 2 meter. Magnitude of C is 1 meter. And magnitude of D is is 1.5 meter again. Although my drawing is not exact. Now they actually find out that magnitude and direction of this A plus B plus C D vector. What would be the magnitude of this vector, and also what would be the direction of that vector? Right. So this is actually that. Basically, these vector are at different location. They're operating, or we can consider this is actually operating a point. Then what would be the resultant force on that object or the point? This is this one actually could be solved by the two procedure. One is the graphical representation, and another is the by the unit vector notation. So we'll solve this is by the unit vector notation. That is called the component method actually. The graphical representation I cannot do over here, because unless if I shift that angle, and which is going to be the precisely the angle are equal, then we cannot do that way. In that case, your component and the angle will be wrong. So that's why it's better to do unit vector notation actually. Fine. To do that one, I'm going to rearrange this vector actually. Look at this. If I want to do that, I will shift the origin of that vector without changing the direction and its magnitude. Say first I'll draw, say that this is that vector A. So this is my vector A. So it's create an angle. So this is the vector A. It's create an angle over here. So 40 degree, right? This is my positive X direction. This is my positive Y direction. This is the negative X, and this is my negative Y. It's a two-dimensional case I'm doing over here. Now, this is my vector A. Vector D is along towards that direction. Right, so this is to be the vector D. Vector C would be towards that direction. This is the vector C, which create an angle 25 degree over here. And vector B would be over here. It's create an angle the 19 degree. So that's mean I just shift all of the vector, take them their tail at the origin. Now it will be easier for me split that vector. So if I could express that vector in terms of basically component I and j, then I can add them together, right? Using that vector algebra. So what would be that component of vector A? So component of vector A, if you use say the different color, say this is I'm going to use for vector A. So this is the vector A. One component would be towards that direction, another component would be towards positive y direction. So that's why the vector A I can write A cos 40 degree I hat plus A sine 40 degree z hat. Am I right? Then I'll find out that vector. I know the magnitude of A, which is 1.5 meter, right? So if you put that 1.5 cos 40 I hat plus 1.5 sine 40 z hat, then you will find out that the vector A, the numerical value would be 1.15 I hat plus 0.96 j hat. So this is with the vector A I express in terms of I and j unit vector. Now what about the vector B? So vector B, I should use the different color. Say that vector B, I'm going to use that color. So this is my vector B, right? Which is create an angle 19 degree. Then one component would be towards positive x direction, another component would be towards the negative y direction. So that's why I can write, so vector B, it should be, what is that magnitude of vector B? Vector B magnitude is probably 2 meter. So V cos of 19 degree I hat minus B sine of 19 degree z hat. You understand how did I write down that one? Because my x component is towards the positive x direction, so that's why I write down the positive in terms of x component, and the y component is negative, so that's why I use the negative sign in front of that y component. I use it in that form, or you can use the trigonometric way basically, because this angle is going to the clockwise direction. Then you can use cos of minus theta, basically cos theta plus b sine of minus 19 degree would be the minus b sine 19 degree, because sine of minus theta basically that minus sine theta. You can use that also, the trigonometric logic. So if you put that one, the b is 2 cos 19 degree I hat minus 2 sine 19 degree j hat. Then b would be, the vector b would be 1.9 I hat minus 0.65 j hat. So this is will be my vector b. Now what about the vector c? You can look at this over there. So I'm going to use the different color for the c. So vector c, look at this. This is my vector c, right? Sorry. So it's create an angle 25, and then your x component will be toward that direction, which is negative, and the y component will be toward that direction, which is actually the positive y direction. Then I can write, it will be that c magnitude is 1. Say that, I'll write in that form, say that 1 cos 25 degree is with the minus I hat plus 1 sine 25 degree sine 25 degree j hat. I just jump one line, so then it would be basically the minus 0.91 I hat plus 0.42 z hat, right? So this is to be basically my vector C. What about the vector D? Say vector D is towards that direction, right? This is the direction of the vector D. Then what will be that vector D x component? It will be 0, right? There are no component of that vector towards the direction of x direction, or you can use that angle because it's create an angle 90 degree with the x-axis. Say I will use that idea, say d cos 90 degree I hat plus d sine 90 degree z hat, and the d magnitude is what? D magnitude is 1. Then cos 90 is basically the 0, right? So that's why this will be the 0. There are no x components. 0 I hat plus sine 90 basically the 1, and this is actually the 1. So that's why you will find out. I'm sorry, d is 1.5. 1.5 z hat. So that's why your d vector would be 1.5 z hat. I find out that component of the d. Now I'm going to add them together to find out all 4 vector. So in that case, the vector A plus vector B plus vector C plus vector D, I'm going to add them all together. So that's mean I'm going to write 1.15 I hat plus 0.96 j hat, which is my A vector. Look at this. And plus V vector. V is 1.9 I hat minus 0.65 j hat. Plus C vector is with a minus 0.91 I hat plus 0.42 j hat, and the D is plus 1.5 j hat. Right? I just put the value of this vector, and if you add these together, you will find out that resultant, which is A plus B plus C plus D, is going to be the 2.14 I hat plus 2.23 z hat. So this is the vector. Now I could find out the magnitude of this vector. A plus B plus C plus D vector magnitude would be, you can find out the magnitude, right? Square root of 2.14 square plus 2.23 square. That will give you basically that 3.1 or 3.09 actually. And the angle or the magnitude is the vector create an angle with the positive x direction, because I'm going to use theta equal to tan inverse y by x, right? Then it should be basically is going to be 46.12 degree. That should be your answer. This is the answer of this question. Do you have any question over here? Any question over here?
No, sir.
Or you can use that formula also to find out the angle between this A dot B, actually that AB cos theta. You can use also that formula. In that case, your one vector would be basically this one, right? That vector. And second vector would be basically the I hat, because you are going to find out the angle with the positive x direction. You will find out exactly the same result. You can check that one. It will also give you the same result. Okay. If can try using that formula to find out the angle between that resultant vector with that x-axis, or any axis you want. Actually, you can verify in it that way. Yeah, fine. I'm done with today. This is the end of your vector chapter. In the next week, basically, we are going to talk about the motion in 1 and the 2D.